Testing, testing, testing. What's going on, guys? I'm here at the Intellic integration offices in Irving, Texas. Got a beautiful view here and got a beautiful backdrop. I'm about to bring on Andrew Geiger. I've known him for a long time. We actually worked on a project a while back for a client, and so it's good to see him. And we're just going to chat informally. Nothing really specific, nothing on the agenda. We're just going to chat and see where it goes. And yeah, hopefully we get some good content out of it. And
want me to sit there?
No. I'm just rolling it out. So yeah, Andrew, check it out.
Cool.
If you want to use the headphones to get a feel for the mic, you don't have to wear them while you're going.
Cool. Hey, that's a really good microphone. That's cardioid design. I always kind of wondered how the geometry of those worked.
Yeah, now this part it ends up being the pain because you can't rotate it. So
Yep. But if it's that design, then as long as you're hitting around the corner there, it should be pretty good.
yeah, it should be good.
Now I can hear my voice in my own head. It's extremely disturbing. Sorry.
Okay.
Put a boom mic in front of me. I'm going to fiddle with it.
Yeah, I love that.
Need me to lorem ipsum it for a little bit?
No,
Okay.
keep talking.
Okay. Yep, that's what I meant.
All right,
I can
yeah,
just say words.
Yeah.
Does it work? So you clap your hands, so you're doing peak detection, kind of like to level it all out.
Yeah. If do you prefer to wear the headphones on or?
Yeah, that's a lot less echoey. That's probably a little bit better. I hit a button on it, by the way, so you may be playing music in the background. Sorry.
Oh, really?
I don't know. Took the headphones off, hit the button. Apologize.
That was the noise cancellation.
Okay. That's how that works.
Okay. Yeah, you're good, dude. So
Neat.
Tell me about your day. How's it going?
Not too bad. Not too many fires today. It's kind of nice. It's a little, there's a couple little problems, but none that other people can't take care of, which is the usual problem. Call tech support and hope someone will escalate it and escalate it harder. And that's been working out not very well at all, but that's not something I can fix. So day's been going pretty good. Working on a couple problems.
How is what's it like being a system integrator for someone who doesn't know what that is?
So there are lots of machines in plants, and they all do and say things, and they're all really, really dumb. So we basically help make the machines talk to other machines, hopefully in a more intelligent way, or at least make some sense of their babblings to the network. In general, that seems to mean that we are collecting data for management to make sense of how machines work. Machines may generate product. Stuff goes in, stuff goes out, and then you're left with things, and that's good, and everyone likes that. But unfortunately, machines don't tell us a lot about how they do things unless we specifically ask for it or set it up. And making sense of that's been pretty much our main focus for a lot of these things. Some system integrators work on very low-level stuff where they just make the machine do anything at all. We tend to come in on machines that are already doing stuff and try to make sense of what they're doing. And sometimes we come in and we try to make sense of the clipboard problem, as I call it, which is operators have clipboards and they fill paperwork out on it and they do their work and they do their job. And then in the mornings, people talk about this and then we throw the paper away, or more likely put it in a filing cabinet and never look at it again. This does nobody any good whatsoever and mostly frustrates everyone at every level of the business. So we try to find ways to get that data in side systems that people can work on. Yeah, that's pretty much it, which
good.
covers everything.
That was really good. So, what do you find most fascinating about what you do?
The more engineering I do, so I started, my background starts as a process engineer on a glass coater, which is a giant vacuum machine that changes, we set fire to nothing, coloring your glass with the soot. Then I went in a shingle factory, which is like a completely different sort of problem. And now I've been doing a lot of integration sort of work stuff. And the more and more and more work I do, the more I realize that machines are like the easiest part of the problem. And using the word problem is kind of touchy because it's not really a problem, right? But it's all about how people interact with each other and how they interact with the machines and what people want. It's all about people, which sounds stupid and new agey in a lot of ways, but it really does seem to work out that way. More and more of the problems are simply coordinating what people actually want from what they think they want and from what they've seen people offer them and having them articulate what they actually need, which I guess is most of engineering. I mean, engineering is like, 70% specification and 30% doing stuff, kind of like programming. The actual time you spend coding is a lot smaller than trying to figure out what to code. So that's a lot of what we do. And that's why when we were talking earlier in my office, I have a couple of computer monitors open and a million Skype windows open. And yes, I'm doing some programming on some of those things and applications, but a lot of it is just talking to people and trying to figure out exactly how to get things work, which is the whole thing this morning about tech support. We have firewalls that aren't open, which means we have automated bureaucratic gnomes stopping us from getting our work done. And we're trying to get that fixed, but everyone's on vacation or in Europe, and it turns out to be a thing. So go figure.
So what are some of your hobbies?
I have a couple. Naturally, I play video games because my friends all tend to live out of state from where I live. So the only way we can keep in touch is hanging out online. And if you wanted a list of games like things like Heroes of the Storm, EVE Online, and like we play Tabletop Simulator to play Uno because Uno is a really good game. We don't do as much anymore because it turns into a bit of Monopoly in the end, and you don't want to lose all your friendships that quickly. EVE Online I don't consider as much a hobby because it's more like work because it is spreadsheets in space, but it can be fun. And at some point, I want to apply our MES technology to EVE Online so I can finally automate some industrial process in that game. I'm sure other people do it, but I think we can do it better. That's a lot of work, though. Other hobbies... Lately, I've been wanting to get back into computational fluid dynamics. I've got a couple combustion problems I'd like to solve, but I need a lot more computational power. I've got a whole stack of servers in the room. I'm trying to get a miniature, like personal cloud setup, which solves a completely different sort of problem. But I'm finding out that like having 120 cores at your disposal is nice for general computing problems. But if you want to do fluid dynamics, you really want to have a few thousand. And I don't know how to do that, so I think I might have to buy some graphics cards, and I don't know how to jam a Titan 1080 inside a server. A lot of servers don't come with high-end graphics card modules in it. Not the cheap ones you can buy off Craigslist for like, $150. So I'm going to be looking into that a little bit. That's for another long-term project that I suspect is going to take at least 10 years to get off the ground. So it's kind of like, the long term, this is my life hobby sort of project. More on that as I figure that out. Or not.
So, about that, like the 10-year plan, like where do you see the industry heading?
Okay. Cloud is cool. Everybody likes the cloud. My interactions with people, and it has been limited, but a lot of people are doing cloud stuff. There are a couple problems in that people get excited about the hype, but they don't know what it's for. They know it can solve certain classes of problems, but they don't know why it solves them better than the problems that they currently have. And so we have people putting data into the cloud, and they're like, yeah, cloud data, and now what do you do? And it turns out some of those things are easier done locally on one honking big machine, which they tend to have. I've been surprised. Everyone has giant servers capable of doing these overnight compute problems, but they would rather do it in the cloud, but that tends to be expensive. I think we're going to find that we're going to get better at doing cloud compute. So in the stellar sequence of, and I use that term a lot, sorry, of how you do these setups, in industrial line, we'll have the clipboard. That's data collection level 0. You've got to do at least that. If you don't have clipboards, then you're really not a serious manufacturer. And then you get the clipboard, and then you want to do something with it. And it turns out you got to put that in the computer, and then you go to level 1, which is get the data from the clipboard into the computer, usually involving access databases and a horrific amount of Excel. And then you want to go to level 2, which is actionable data on that clipboard data, like holding things accountable for failing. And then you go to level more and more. And you want to act on that data and have automated processing of that data. And then you want to do analytics. And that's like level 4 or 5 down the line. This is not official leveling stuff. You're going to hear buzzwords in the industry. I don't use buzzwords. I don't know what they mean most of the time. So that's something else entirely. So when people talk about levels, I'm not using that term. We're going to find that cloud compute, what a lot of people call cloud compute, is really just them getting into the put data somewhere. And now they've got a problem. They still have the problem of how do I compute against it? And there's initial work on doing that, but they're still left with the problem of how do I make sense of that data? We're going to find a lot more effort going into making sense of the gobs of data we have. If we look back in the 80s, there was the expert system craze, where people would design systems that would make sense of all that data in predefined ways that experts defined. Then we've got the AI stuff that's coming out with the machine learning. And we're going to go one step further, which is probably going to be the informed machine learning stuff that I think we're going to have a lot more success with. You can't just machine learn everything, because manufacturing processes generate a lot of data, but not like ginormous amounts of data. So for really good machine learning algorithms dealing with sparse information, that can be kind of difficult, especially when that information is error prone or garbage, because machines lie constantly. You got to take the house MD approach to understanding and trusting your data. So I think you're going to find that people are going to they're going to get to know their data better. They're going to have better ways of analyzing data, and they're going to have it more easily accessible, because when we get people data, we also have to make sure that like analysts who don't know anything about manufacturing can take something like, there's a great piece of graphing software a couple of people have been using. Actually, I have a friend, that and Tabula, and I have a roommate from college who's just going to kill me because I couldn't remember the name of it. Someone's going to remember. Leave a comment, like, and subscribe. It's going to be, people are going to learn how to better analyze it. That's always been the problem, right? Like, just giant amounts of data, but not so much data that you can have a system learn itself. If you look at Peter Norvig, he has a whole bunch of IPython notebook posts where he describes Python programming stuff, where he shows you in his brilliant sort of way how simple it is to solve certain types of problems. And he has a great essay on the bizarre effectiveness of data, wherein if you have enough data, you sometimes don't even need to know what you're doing. And if you want to build a spell checker, for example, if you have the entire corpus of the English language with all of the words in it, and you throw that at an algorithm and just say, hey, tell me the most commonly used ways people do these things, you can build a spell checker without actually knowing how to do spelling. That's kind of the magic of machine learning style stuff. I don't know what I'm doing, but I'm right. But we don't have that much data. And a lot of times it's really bad when you can model a line. How do you generate models of things? Because I have a background in physics, so everything I do is model based. So what if you have a line that hasn't been running for 3 months? You've got no data. How do you act on anything it says? Is this unusual? Is this normal? Who knows? We're going to start to learn how to deal with those things much better. And I think bootstrapping is the big problem people have right now. It's going from all this stuff and making sense of it the first time. I mean, once you get the process and pipeline down, I mean, you can just do that and run it for years. People use Excel sheets that point to other Excel sheets, that point to other Excel sheets, and then loop back on themselves. And one guy knows if I open this one in the morning and hit F9 at just the right time, it'll magically work. And if I do it any other way, the whole thing implodes on itself and breaks. And then they do that for years, and it's fine. Doing that better would be nice.
Awesome. Thank you, Andrew. Do you have any final closing statements?
I talk about things. Feel free to ask anything. I'm usually available via most means. If you take my name and put it in front of something, you'll probably be able to get my attention.
All right. You want to say what's up to the LinkedIn fam?
Hi. I should use LinkedIn more. I'm on it. I should probably comment on this. Be the first thing I've ever commented on.
So just say, what's up, LinkedIn fam?
Fam?
Fam, yeah, F-A-M.
Okay. What's up, LinkedIn fam? Someone's going to make fun of me for that.
Love it, dude. That's a wrap.